Session 4.1 Basic Concepts of Probability. Definition: we have an event, simple event, compound event, and also the sample space. Let us look at this example. Flip the coin. Okay, this is the event or the procedure. Flip the coin. And when I flip the coin, I only can get head or tail. Since we only have exactly one outcome, we call this as a simple event. And in session 4.1, we only cover about the simple event. And for the next sessions, we will talk about the compound event. And in sample space, this consists all possible outcomes. Like when I flip a coin, I only can get head or tail. So we call this is the sample space. And you guys need to know how to write out the sample space. Okay, notation for probabilities. P, we use the P stand for the probability. And then we could let the event A, event B, or event C. P of A means probability of the event A occurring. Okay, for example, when I roll a 6-sided die here, okay, this is a 6-sided die. I have my sample space. When I roll the die, I can get 1 or 2 or 3 or 4 or 5 or 6. That will be my sample space. And for example, let's say I let the event A, that will be obtain an odd number. If I want to find the probability that obtain an odd number, so look at the sample space. Odd number, it can be 1, 3, and 5. So I do have 3. Out of the total outcome, 1, 2, 3, 4, 5, 6. Out of 6, which is going to be 1/2. So this is going to be my probability. And all the probability, it has to be in between 0 and 1. It cannot be negative, it cannot be greater than 1. The probability of an event that cannot occur is 0. So think about it. Let's say this time I'm gonna let my event B equal to obtain is 7. Okay, in number 7. So what is the probability to obtain a number 7 when I roll the die? Okay, look at the sample space. I don't have the 7 here. So the probability to get the 7, that will be 0. Over the total outcome, that will be 6, which is going to be equal to 0. So this means the probability of the event that cannot occur is going to be 0. So no matter how many times I roll the die, I won't be able to get the 7 in here. Okay, the probability of an event that must occur is going to be 1. Okay, another example, I'm gonna let's see equal to the event. I will get the number equal 1 or 2 or 3, 4, 5 or 6. Okay, so what is the probability to get the C? So I can get any number in here, right? So that will be 6 over 6, which is going to be equal to 1. So the probability of an event that must occur is going to be equal to 1. Okay, and then for the probability, we do have 3 different types of a probability. First one, classical approach to probability. It's applied to compute the probabilities of the event for an experiment in which all outcomes are equally likely. So we do have the formula here. Number of the outcomes favorable A over total number of the outcomes for the experiment. So look at the example we just did in here. Number of the outcome favorable A. If I want to obtain an odd number, I do have a 1, 3, 5. Okay, so 3 number that will be favorable A over the total outcome. The total outcome that will be the 6. Okay, classical approach to probability. This is like we can calculate it. Okay, that's by calculation to get the answer. Okay, another example that will be toss a coin to get a head. Okay, I can get either head or tail. So the probability to get the head that will be 1 over 2. Again, this is by calculation. Okay, compute. Number 5, relative frequency approximation of probability. Conduct or observe a procedure and count the number of times that event A actually occurs. Based on this actual result, probability can be approximate as follows. Number of times A occurred over number of the times the procedure was repeated. So for example, let's say now I stand on the freeway from 1 o'clock to 2 o'clock. And then I'm gonna count how many cars a blue column is gonna be passed by. So I'm gonna count it from 1 o'clock to 2 o'clock, 1 hour. For example, I do have a 50 cars for total. And I only have like 7 cars a blue pass by. So this is I perform the experiment. And then find out the probability. Okay, since this is a by experiment, so for example, like if tomorrow I'm gonna do the same experiment from 1 o'clock to 2 o'clock, stand on the freeway, I may get exactly the same result. Okay, because this is by experiment. So the difference between classical approach and the relative frequency. The classical approach, this is by calculation. Okay, you will get the same answer no matter how many times you calculate it. But for the relative frequency approximation, this is gonna be conduct a procedure or conduct an experiment. So you may get a different answer. Okay, number 6, subjective probability. This is the probability assigned to an event based on subjective judgment, experience, information, and belief. For example, I see this student, Carol. She come to class every day. She turn in all the homework and job notes, and I believe she can earn an A in this class. Okay, but this is only my experiment or subjective judgment. It may not be true. Maybe final, she dropped the class or she got the fail. Okay, and we call this as a subjective probabilities. Okay, determine what type of probability is relative frequency, classical approach, or subjective. Okay, I want you guys try on it from A to E. Okay, A, randomly selecting someone who is married. Okay, so this is just like the experiment. So this is a relative frequency. And then B, couple plans to have 7 children, probably to get 2 boys. So we assume we do have the same chance to getting boys and girls. We have like 50 and 50. And the children planning to have 7 children and probability get 2 boys. So we can calculate it by calculation. So this is going to be the classical approach. And C, obtain an even number in one roll of die. So when I roll the die, I want to get the even number. Again, can be by calculation. So classical approach. D, tossing of an unbalanced coin will result in a head. Okay, since this is unbalanced, we don't know like what is the probability to get the head or the tail. So this just similar to you perform the experiment. So that will be relative frequency. And then E, Joe will lose the lawsuit he has filed against his landlord. So this is subjective. Okay, and for this session, the basic probability, most of the questions we're gonna working on the classical approach. Okay, that's by calculation. Okay, example 2. Find the probability of obtaining an even number in a one row of die. So this is by calculation. We will apply the classical approach formula. Okay, and when you roll the die, you have the sample space, the 6 outcome, 1, 2, 3, 4, 5, and 6. And I just let the event A become my even number. That will be 2, 4, and 6. So we're gonna use this formula. Okay, how many number of the outcomes favorable A? So in this total outcome, I do have 2, 4, 6, which is 3. And total number of outcome, that will be the 6. So it's going to be 3 over 6, simplify it, that will be 1/2. Okay, try the example 3. 30 people were asked about the colors they like, and here are the results. Red 10, blue 15, and green 5. If a person is selected randomly, what is the probability that this person likes the red color? Okay, so the favorable outcome, that will be the 10, right? The red color is going to be 10. And over the total outcome is going to be 30. Okay, so it's going to be 1/3. Okay, if number 4 is 2 dicks a wall, what is the sample space? I'm not asking for the probability. I'm looking for the sample space in here. So can you guys try to write out the sample space? Okay, gonna give you guys in here. So now I have 2, 6 dice here. Okay, I want you guys write out the sample space. Okay, for example, the first time when I roll the die, I can get the 1 in here. Alright, the second one, I can get the 1. Or I can get the 1 for the first die. Second one, I could get the 2. Or 1, 3, 1, 4, 1, 5, 1, 6. Okay, or second one, it can be like, first one, I got the 2. Second one, I got the 1. 2, 1, 2, 2, 2, 3, 2, 4, and so on. Okay, try to write out the sample space in here. So you should get this. Okay, how many total outcome do I have? I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I have 36 total outcome. And again, this is the sample space, not the probability. Okay, B, what is the probability if the sum of two numbers is equal to 4? Okay, sum of the two numbers is equal to 4. So look at the sample space. Sum of the two numbers equal to 4, it can be like 3, 1, 2, 2, and also 1, 3. Right? When you add it up, that will be equal to 4. So this is gonna be my event E in here. Okay, the possible outcome. So what is a probability? That will be, I have 1, 2, 3. 3 over 36 for total outcome. Okay, so it means like 1/12 in here. Example 5, 52 paying cards. We have a 4 shoots, clubs, spades, hearts, and diamond. And we do have 13 of diamond, 13 of clubs, 13 of hearts, and 13 of spades. And for the number, you could see we're starting from 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have a jack, queen, king, and also the ace. So total, we do have a 52 cards. And then now we want to calculate the probability of drawing a green of diamond. Okay, so we only have a 1 green of diamond out of 52 cards here. So probability a green of diamonds, we only have a 1 out of 52. 1, 2, 3 decimal space. Okay, and I want you guys try the part B and part C. Okay, B, calculate the probability of drawing a line. So you could see the picture here. We have 4 9 cards out of 52. So that'll be 0.077. And then we want to draw a club. So we have 13 of club out of 52, which is gonna be 0.25. Okay, number 6. When 3 children are born, find the probability of getting 3 children of all the same gender, assuming that boys and girls are equally likely. So I will have 3 children, and I want to find out the probability of same gender. So same gender means I want 3 boys or 3 girls, right? 3 boys or 3 girls. But you guys need to figure out what is the total possible outcome. So in order that, I want you guys try to write out the sample space. Okay, the sample space means like I could get boy, 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 or I could get boy, boy, girl, right? Then order doesn't matter. So I could get boy, girl, boy as well. Okay, I want you guys try to write it out the sample space with 3 children. So check your word. You should have this one, right? Boy, 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 girl, boy, girl, boy, or boy, girl, girl. So again, the order doesn't matter. So boy, boy, girl is different from boy, girl, boy. So total, you could find we do have 8 different outcomes in here. Okay, sample size is going to be equal to 8. And then I want to find the probability that 3 children of all the same gender. So we have 3 boys or 3 girls. So that will be 2 out of 8. Okay, definition. An event is unlikely if its probability is very small, such as 0.05 or less. Okay, so every time when we ask for the probability, if it is an unlikely event, you need to think about this number. Okay, the probability has to be less than or equal to 0.05. If the probability less than or equal to 0.05, we call the event is unlikely. Okay, try this example. Kelly asked Mike to guess the date of her birth, not including the year. What is the probability that Mike will guess correctly? Would it be unlikely for him to guess correctly on his first try? So try find out what is her birthday, how many days of her birthday, out of what is the total outcome. Okay, you only have a one birthday day out of 365 days for a year. You should get this. And this event, is it unlikely? Yes, right? Since the event is less than or equal to 0.05, so we call this probability event is unlikely. Okay, last one. If A is any event, the complement of A is the event that it does not occur. So the notation for the complement of A, it can be like A bar, or you could have an A and then put the C on the right hand corner. For example, like if there's a 60% chance of win today, then there is a 40% chance that it will not win. Okay, it win and it will not win. When added up, it has to be equal to 100%. Okay, and we call this as the complement. Okay, let's look at the complement formula. Okay, P of A plus P of complement A, that will be equal to 1. Just like this example, 60% chance of the win, and there's a 40% chance that it will not win. When you add it up, that will be equal to 1. Okay, and we also play around like this formula. We could subtract it. So the P of A, that will be equal to 1 minus P of complement A. Okay, let's look at this example. In May 2008, 42% of cars sold were small cars. What is probability that a randomly chosen car sold is not a small car? Okay, a small car and a not a small car. So that is the complement. So we could apply this formula in here. All right, probability of not a small car equal to 1 minus probability of small car. And remind you guys, don't use the percentage in the probability. We could change it to the decimal in here. Okay, so that will be equal to 0.58. Okay, the complement, we're gonna talk about it again on the session 4.3. Okay, and that's it.